Welcome back. Now, in this video, we're going to talk about hit events. We would like to detect when the projectile hits something, and that way we can do something in response, such as destroy the projectile, and later we'll handle doing damage and causing explosion effects and things like that. So let's talk a little bit about hit events. Now, our projectile has a mesh component. Its type is U-static mesh component, and U-static mesh component is one class in a long hierarchy of classes in the Unreal Engine system. One of its parents is U-primitive component. Here is the documentation page for U-primitive component. It says U-primitive components are scene components that contain or generate some sort of geometry, generally to be rendered or used as collision data. So they're basically scene components with some added features. And if you scroll down and look at the hierarchy, you'll see that we have U-scene component, and derived from that, U-primitive component. And you can keep scrolling down and see all of the other classes that derive from U-primitive component. Now, the reason we're pointing this out is because U-static mesh component inherits these features from U-primitive component, and U-primitive component has the ability to generate hit events. Now, what do we mean by generate hit events? Well, let's say we have some geometry in our world represented by the rectangle to the right, and we have an object with a static mesh component represented by the circle to the left. Now, if this object that has a static mesh component is moving towards the block, then if this component is set up to handle hit events, then as soon as it hits that block, the hit event will be generated upon collision. Now, a hit event will generate some data pertaining to that collision, including the component that was hit. So this block here may have a static mesh component. We can access that component upon colliding. We can also access the actor that was hit. And the hit event also generates an F-hit result. We've learned a little bit about the F-hit result, and we know that it contains lots of variables about the hit event, such as the hit location, which is an F vector representing a location in the world. So we have our projectile mesh. This is a variable of type U-static mesh component pointer. Now, whenever this static mesh component hits something in the world, we want to have some code that responds to that. Now, being a static mesh component, it inherits things from the U-primitive component class. One of the things it inherits is a variable called onComponentHit. Now, here's the documentation for onComponentHit. It's described as an event called when a component hits or is hit by something solid. Now, scrolling down, we see that onComponentHit has the type fComponentHit signature. And if we click on this, we see that fComponentHit signature is a struct. Now, going back, we can see that the documentation says an event called when a component hits or is hit by something solid. This could happen due to things like character movement, using set location with sweep enabled, or physics simulation. For events when objects overlap, such as walking into a trigger, see the overlap event. So there are hit events and there are overlap events. We're concerned with hit events. So we know that onComponentHit is described in the documentation as a hit event. And we know that onComponentHit is a struct of type fComponentHit signature. So far, so good. Now, this hit event onComponentHit is also something we refer to as a multicast delegate. A multicast delegate can have multiple functions bound to it. There can be functions that exist on multiple classes, and if those functions get bound to this multicast delegate, then they're added to something called an invocation list. This is a list of functions to be called when this hit event tells them all to be called. We say that this hit event or multicast delegate broadcasts when something happens. So in the event that our projectile mesh hits something, then the delegate will broadcast to all classes that have a function bound to this delegate. As soon as that broadcast is sent, then all of these bound functions are called in response to the broadcast. This is a very powerful feature of Unreal Engine. It allows us to have this thing called a delegate, which waits for an event, such as a collision, and then the delegate will be broadcast, resulting in all bound functions called in response to the broadcast. Since multiple functions can be bound to this delegate, we call it multicast. It's broadcasting to multiple classes that have their functions bound to it. Now, how do we bind a function to this delegate? Well, onComponentHit has a number of functions that allow us to do this, one of which is called addDynamic. So when we call the addDynamic function, all we need to do is pass in two parameters, the user object, which we can use this for, and the callback function, which is the address of some function on our class. So once we access this onComponentHit delegate and call the addDynamic function, we can pass in the user object and the callback, and this will result in adding that callback to the hit events invocation list. Now, onComponentHit will broadcast this delegate, resulting in any functions bound to it to be called. So in order to bind to this delegate, we need to create a callback function. So here's projectile.h, and we'd like a callback function for the hit event. So let's create a private function here, and it's going to be void, and I'm going to just simply call this onHit. We could call this anything we want, but onHit seems descriptive enough. Now, this callback function has to have the correct signature for hit events, which means its input parameter list needs to be very specific. The first input parameter has to be of type uPrimitiveComponentPointer, and it's called hitComp. This is the component doing the hitting. In our case, we're going to have our projectile mesh hitting things. The next parameter is an aActor pointer called otherActor. This is going to be the actor that got hit. The next input parameter is another uPrimitiveComponent pointer called otherComp. This is the other component that was hit. So if we hit the static mesh component of some other actor, then this would be that static mesh component. Next is an F vector called normal impulse. If we're simulating physics, the physics engine will apply an impulse in response to the collision, and this F vector represents the direction and the magnitude of that impulse. And finally, we have an input parameter of type const, fHitResult, and this is a const reference, and it's called hit. So when onHit gets called, we'll have access to a hit result that contains even more information about the hit. Now, since we're binding this to a delegate, it has to be a ufunction. So we're going to mark this with ufunction. Now, you should be familiar with ufunction. It's just like uProperty, only it's for functions rather than variables. So very important, our callback has to be a ufunction for this to work. Now, we've declared the function. Let's go ahead and define the function. So back in projectile.cpp, just under our tick function, let's define this function. We'll give it a function body and put the class name just before the function name. And now we have a callback function. So we're ready to bind this onHit function to our delegate, and we need to do this in begin play. Doing it in the constructor is too early, and sometimes you can run into issues like your delegate not being bound. So we're going to do it here in begin play. So we have our projectile mesh, and we'll use the arrow operator to access the variable inherited from uPrimitiveComponent called onComponentHit. And onComponentHit has the function addDynamic. This is the function we'll use to bind our callback to onComponentHit and add that function to its invocation list. Now, first we need the user object. That's going to be this because this is the class we're binding the function for. And next we need the address to the function. That's going to be the address of onHit. So we'll use the address of operator and the function aProjectileOnHit. And with this, we have our function bound, and we're ready to generate hit events. Now we can test this out with a UE log, and we can use logtemp, warning, and for the text, we can simply say onHit. And if we see this in the output log, we know that our onHit function has been called. Let's compile this. So I have the output log open here. I'm going to press play and fire a projectile. And there's my log message. OnHit is being called. So this is working. Now, just a side note, if we go into BP projectile and select projectile mesh, in the details panel, we can scroll down to the collision section. And here we see that the collision presets is set to block all dynamic, and that collision enabled is set to this setting, collision enabled query and physics. This is necessary for hit events. We need to be able to query for a hit event, and of course physics allows the physics engine to act on the projectile mesh. So now that we've bound to the onComponent hit delegate with our onHit function, and we've placed a UE log to make sure that it's working, I'd like you to explore this function a little bit more so that we can understand some of these input parameters in our onHit function. So in the onHit function, add some more UE logs. I'd like you to print the names of some of these input parameters using the getName function. I'd like you to use a UE log to print the name of hitComp, other actor, and other comp so that we could see the names of these objects we're hitting. You're going to use the %s format specifier in the UE log text macro, and just as a reminder, whenever we call getName, we have to use the asterisk when passing that string into the UE log macro. For example, to get the name of other actor, we would call other actor getName and place that asterisk at the beginning just to return that C-style string, which is what UE log expects when you format it with a string. So pause the video and use UE log in our onHit function to print the names of hitComp, other actor, and other comp now. Okay, so here in projectile.cpp, I'm going to use UE log here. So I'm going to copy this line where I'm using UE log, and for the string, I'm going to say hitComp, %s, and just after the text, I'm going to call hitComp getName, and I need this asterisk to convert from an F string to a C-style string. Now, I'm going to use this same line, only I'm going to change the text to say other actor, and we're calling getName this time on other actor. And finally, I'm going to print other comp, calling getName on other comp. So let's compile. And back here in the editor, I'm going to go ahead and hit play and shoot a projectile. And check this out. We see that hitComp is projectile mesh. Remember, we said that this is the component doing the hitting, which is our projectile mesh. And you'll see that it's using the name that we assigned to this component in create default subobject. So this is one of those situations where that name is being used. Now, you'll see that it says other actor floor_0. And that's because the static mesh actor, that is the floor, has the name floor_0. Sometimes the engine will place a number at the end of its internal name for actors and components. And you'll see that we have that same thing happening when we print out other comp. The floor static mesh actor has a static mesh component, and its name is static mesh component 0. So this gives us a little bit more information about those input parameters in our onHit callback function. And this is useful because we have access to those objects in C++ if we'd like to do something in response to the hit event. So in summary, we have learned about hit events and how these are implemented as multicast delegates, and we learned how those work. We created a function called onHit and bound that function to the onComponent hit delegate that our projectile mesh has inherited from the uPrimitiveComponent class. Now, we haven't destroyed the projectile onHit, but we now know that we can easily do so because we have this callback function, and we can place logic in this function, such as destroying the projectile. So we'll handle that in a future video. For now, pat yourself on the back because this is one of the more complex areas of Unreal Engine C++ that you've learned so far. I'll see you in the next video.